Okay, so finishing up our lesson on hyperbolas, our day 2, not every hyperbola will be nicely and concisely written in squared form, where we can quickly find the center and find all information to be able to make our little rectangular box and find our foci and quickly graph everything out. Like I said, I think we actually dealt with much of this problem yesterday. If not, it was exceptionally close. I just began to speak of it a little bit. Group your y terms together. They appear to be positive. We'll move them off to that far left-hand side right here. I'll say negative x squared. Keep the minus 2x over here as well. And let's move our constant of 11 to the other side. Now, I do want to say something. Some of you might wonder why I started off saying it appears that y squared is going to be positive. That might have seemed to be a very strange comment. I do want to state the obvious fact that the right-hand side will sometimes arrive to be a positive value, sometimes arrive to be a negative value. That can change what could be our final graphing form. What I'm guessing at is so very often kids look at this and they'll say, look, Mr. Dobner, y squared is positive, therefore the hyperbola opens vertically up and down. We don't know that yet. We don't know that yet. Things can change considerably. And there will be some problems where that will happen. But look, suffice it to say, what you can do is first factor out whatever your lead coefficient is. Factoring is really undistributing. It's really dividing. Distributing is dividing, so distributing is multiplying. So factoring is dividing. So I'm going to factor out a negative 1 here. So in other words, I'm going to divide by a negative 1 for both of these values. And now I'm going to complete the square. Completing the square will always take half of our linear term. The linear term right here is negative 4. So you can see I'm taking half of that negative 4. I'm going to get negative 2. You don't have to do this. I always do, though. I put a star there saying I'm not done seeing that. And then I'm going to take negative 2 and do what? Square it. And you'll get a 4. Now, please realize I'm going to say plus 4 in here. What did I really add on that left side, though? 16 if you distribute that 4 back in. So I'd have to add a 16 to the right side. In a similar way, you can say, well, I need to complete the square with my x's. And that means I'm going to take half of my 2. That's a 1. I can put a little star there. And say 1 squared is a 1. So I'm going to say plus 1. What do I write on the right-hand side, though? Negative 1. And sometimes kids will say, well, wait a minute, you just wrote plus 1. Oh, don't forget, I had negative 1 factored out in front. Okay, so be careful with that completing the square. In that regard, that's a little bit more tricky than the ellipses, of course. Well, the right-hand side, thankfully, works out to a positive. It won't always do that. Sometimes you might see the right-hand side adds up to, say, a negative 4 instead of positive. Well, then what? Over here we'll have 4. What does this squared term really become? This becomes y minus 2. Sometimes kids will almost look at that and be like, how do you know that? Look at where you put a star. Look where you put a star. The star reminds you what goes inside the parentheses. Always. And then you come over here, you'll say, here's my minus. Well, guess what this thing's going to factor into? It's going to factor into x plus 1. And hey, look at that. Right now, at least, we're a lot better off. We're looking so much better. To get this into a much friendlier form, though, what do you think we're going to do? Divide by 4. You know it. And then I'm going to be left with y minus 2 quantity squared all over a 1, squared if you'd like, I'll say here's x plus 1 quantity squared all over 4, but you could call that a 2 squared if you'd like. Then you have a 1. Now I hope things look way more familiar. Would my hyperbola open vertically, up and down, or horizontally, left and right? What do you think? Vertically, because the y expression is positive. Okay? So it does ask us to analyze. And to be sure, you could also graph. But help me out. What's your center? What would your center have to be? X comma y. Guess what we'd get? Look at the parentheses here. -1 comma 2. Right? Change the sign inside those parentheses. And then you're good to go. And right now, sometimes kids are almost like, well, wow, could we actually begin to graph because that helps me? Of course you could do that. I know they're not officially asking for that, but hey, the further we take this, the better. -1 comma 2 is right here. That's your center. And then going up and down, how much should I go above and below my center? 1. The number underneath the y squared term gives me the vertical distance that I need to move. So I'm going to move 1 step up, 1 step down. By the way, that's where my vertices are going to be. You can see I'm going to be at -1 comma 3 and -1 comma 1. Sad to say that we don't have this nice benefit of just writing a plus minus when your center gets slid over. It's a little bit more work. But hey, at least as we're moving on, you can say, well, wait a minute. Horizontally, we should be moving 2 steps to the right and 2 steps to the left. And that's going to help us build our little box. Now, forgive the sloppiness. I don't think I made the nicest looking box here. But that's okay. You know, look, I know they didn't ask for this graph, but right now, having everything in here, knowing that my hyperbola opens vertically, look at that. I've got a pretty good idea as to what that thing looks like. Let's think about the asymptotes. Could we get the asymptotes taken care of real quickly? Go to point slope form, guys, when you're writing asymptotes. Guess what the point shared by the two asymptotes are going to be? It's your center. So you can write y minus 2. In this other parenthesis, you'd write x minus -1. That's x plus 1. As so many kids will notice, going back to the general form, it's as if kids are saying, hey, look, it's those parentheses squared. It's just that you don't have the squared terms. They're showing up in the equation of the line. You bet. Help me out with rise over run. From my center, how much am I going up? I'm going up. How much? 1. Then I went 2 steps to the right. You could have plus or minus there. And tell you what, let's find the foci. C squared is equal to A squared plus B squared. A squared, by the way, which one do we call A squared? It's the 1. It's not necessarily the biggest denominator. It's the denominator with the positive term. And B squared then, of course, would be a 4. Oh, here we go again. C squared is equal to 5. You could say C is equal to radical 5. Oh my gosh. Wow. So maybe let's find the foci and we can even graph them in a minute. Foci go from the center. What direction am I moving? Up, down, left, right? What do you think? Down and up. Here's the cool thing, guys. You could, because I'm going to be moving up radical 5 and down radical 5, I can go back and just say 2 plus or minus root 5. Root 5 is a little bit bigger than 2, so I'm going to be moving up 2 steps and then a little bit more. I'm going to go down 2 steps and then just a little bit more. And there are my foci. Okay, we doing okay? Last one. Write the equation of a hyperbola given foci at plus or minus 10 comma 0. Sometimes kids are like, yikes. You gotta be kidding me. My foci are way over here and here. Hey, by the way, where do you think my center is then? 0, 0. It would be the midpoint of the foci, always. The center is the midpoint of the foci. By the way, if this is my center, how much do we have for that focal length? What's my C value then? C would have to be 10. Now it gets interesting. Kids would be like, wow, y equals plus or minus 4/3 x. Guys, please understand something right now. This is so important. Would my hyperbola be opening vertically or horizontally, do you think? Which direction? Horizontally. So I've got to have x squared being the positive. You have to have the y squared term being the negative one. And usually kids will look at this and they'll say, well, wow, Mr. Dobner, this is kind of nice. 4/3, you're saying go up 4, go right 3. So, you know, you're telling us that we're going to rise up B, go over A. You can almost envision like a little box being made. And kids will say B over A, rise over run, Y distance over X distance. That's the important thing. You could say is even, you could look at it as 4/3. Now here's the huge question at hand. Can I now say A is equal to 3 and B is equal to 4? That's the big, big question. Sometimes kids are like, well, of course. I mean, look, it's right there. B equals 4, A is equal to 3. Well, wait a minute. C squared is equal to A squared plus B squared. Wait a minute. If B was equal to 4, and if A was equal to 3, would I wind up getting this to add up to a focal distance of 10? Uh-oh. Uh-oh. You see, that's what will make kids get so upset. They'll be like, 9 plus 16, hey, that's 25, and C squared should be 5. And you're like, wait a minute. I'm getting 10. They're telling us that the distance is 10. Guys, please understand this. Slopes could be reduced. Right? Slopes can be reduced. You know, it's not guaranteed. Watch out. This is such a huge issue. Kids look at this and they'll be like, oh, so B is 4, A is equal to 3. No, listen, here's what you could do to definitely find out what it is. You could cross multiply. You could say B is equal to 4/3 A. And then you could go back over here and go ahead and plug in your B value of 4/3 A. You could substitute that in. I already know my focal length is 10. 10 squared is 100. And, excuse me, this is 4/3 A. You know, B is equal to 4/3 A. So this would become 16 over 9A squared. How about I get a common denominator of 9 over 9? 9 ninths plus 16 ninths is 25 ninths. Wow. How about I multiply through by the reciprocal on both sides? 25 goes into 100 4 times. 4 times 9 is 36. Aha, guess what A squared is? A squared is 36. A is 6. B, remembered, was 4/3 A. So it's 4/3 times 6, and that's going to be 8. So, guys, what do you have? X squared is 6 squared. X squared over 6 squared minus y squared over 8 squared. This is the equation of the hyperbola you're really looking for.